Okay, so let me first set the context with this simple diagram, and then we will get into the discussion mode. By the way, I have a hard stop at 12:30, so please don't mind. So fundamentally, when we think of applications, right? Any software application, the main thing that we're dealing with in any application is data and its movement. So if you think about any application, it's all about data and its varieties of forms, right? So the foundation of any particular application or any architecture, software architecture is data. And our viewpoint today is WizKid Gurukul. WizKid Gurukul, purely from a software viewpoint, is a collection of multiple different software applications and services, right? So it's not just one application, it's multiple applications. And today, if you really see this picture, and as we go into the details of it, you will understand, there also it's a limited view, which is learning and teaching viewpoint. We haven't yet brought the sales, marketing, operations, so on and so forth, right? And when we think about data, data has certain qualities. Data is at rest. How does the data look when it is at rest is one viewpoint we can have. When data is moving, how does it look is another viewpoint that we can have. Today, our focus is how do we look at data at rest? And what is the value of that? You will be able to identify data and its structure and how it is related to other data elements, right? So far, it's so clear? Yeah, okay. So, based on our so far discussions, whatever we have had with Prabhuji and the rest of the team, and our last discussion, what I've done is, this is a high-level data model, looking at WizKid Gurukul from the perspective of data. That's why it's called a data model. And there are 3 layers that I'm recommending that we identify. First, what I call as foundation, then the app, and then the intel. Okay. So the foundation is, there is intel. If you see, there's a name given at the left side for each of the layer, intel, intelligence. Okay. Intelligence means, see, when you have data, right? Take a simple example. Let's say you have attendance data. Day in and day out, for 100 students, you have attendance data. After 1 year, you can ask questions such as, tell me who is the student who has always been very, very prompt. You can derive that analytics you can generate, right? So such analytics, which is already there in the data, it can be of 2 types. Fact, how many students are there, how many days each student attended, who is regular, who is not regular. It's something like a fact. It cannot be modified. Then there is something which is related to future, prediction, right? So that is what future is. So in data, generally there are these 2 qualities. There's a factual quality and a future quality. The future quality is where you bring in all these kinds of machine learning models. Fact is where it is generally referred as either basic analytics or advanced analytics. But that's all analytics. It's slicing and dicing data in different ways. So that is the intel layer. So the intel layer requires content. And the content is going to come from the foundation and the app layer. In any typical architecture, software architecture, like our Gurukul architecture, application is like transactional systems. Transaction systems are the ones which have day-to-day movement happening in them. Teacher made, student made, they are doing something in it, right? Day in and day out. And how it is happening is what you want to infer through the intel layer. And the foundation layer data is generally relatively static, right? It can also change, but it is, okay, rather than using the word static, let's call it as, it's a foundation for our architecture. Okay. So now at the foundation layer, you are finding 3 main elements. Okay. So the way we are organizing this is the data viewpoint, and each of the small boxes in each of the layer. So first perspective is, I've cut them into layers. so that our focus can be on which layer we are working on. Then second one is within each layer, you can find, I've grouped them into what I refer as schema. So each of the box that you see there is a schema. What is a schema? Schema is, think of it like now, if you think about this home, right? There's a blueprint of this home. As soon as you enter, there's a hall, there's a guard room, kitchen, room 1, room 2, so on and so forth, right? So from the top, when you look at it, you can see different rooms and their relationship with each other. Yeah, let him. Them is what is generally called as a schema. Schema is, and like how this space has rooms and some kind of a function and some kind of a movement, right? That is the relationship. How you can move to that room. You cannot simply jump. So you have to move like this. So like that in a data world, schema essentially has broadly two kinds of things: entities and their relationship. In our last session, we already touched upon the entity and relationship. So there are certain groups of items which you call as entity. As soon as you start seeing any particular story, right, of a given use case, you can identify the nouns in that story. So user, say students come in and log in to student mate. Students learn lesson. Students take assessment. So if you notice these three sentences, student is a noun, lesson is a noun, assessment is a noun. So like that, you start identifying immediately the entities, right? And then you also immediately can identify through these stories relationship. Student takes 1, 2, 3, many lessons, many assessments. So there's a 1 to N relationship. Student is a child of a parent. So one parent may have more than one child. So like that, as you can see, among the nouns, you start seeing relationship, right?
Like student to teacher is many. One student can have many teachers.
Many teachers, right? So like that, the moment you read a story in a use case, you pick up the nouns, right? And you can also very intuitively, human beings are very good at it. Ear diagram is just a representation of that, but intuitively humans are very good at ear modeling. You immediately know the relationship, right? It is a very simple science. So that is the within the schema, right? But within the schema. Right now, this picture that you're seeing is at a schema level. So the whole model has been broken into layers. Layers have been broken into small units called a schema. Within the schema, we will be deep diving. Okay. Our conversations will be hovering around the schema. Within that schema, we will have entities, relationship, and every schema will have a schema owner who, meaning which of our service or which of our application owns that particular schema. By that, what we mean is who can create those entities within that schema. So for example, if let's say registry, there is a schema called registry. What's the concept of registry? That is where all our different items are going to be simply cataloged. We have gurukuls, we have students, we have parents, we have teachers, we have maybe physical assets. So n number of things are there. Without worrying about how they're related to each other, we may simply need how many students are there, how many teachers are there, how many parents are there, how many laptops we have got, so on and so forth, right? So registry is simply a log of all the distinct items that we have. Now, who should own the registry? Who should write in the registry? Can any service and can any application come and read and write from the registry? These things matter. That way you maintain a certain structure around it. Who should write? Who can read? And if they have to read, how they can read. So these are the aspects that we will bring in the security schema. If you notice, there is a schema called security. So security enables two main functions in any architecture like this. One is authentication, another one is authorization. Authentication is who, right? Who is wants to look at this data? Who is that? Is it Gayatri? Is it Shravanji? How can I ensure that it is actually Shravanji who's looking at it? That is the who part. And then what they can see. Can Gayatri see data from, let's say, all the 3 applications, or can Gayatri see data from only one particular application? So authentication, authorization, all such kinds of data will be maintained in security. Knowledge. If you look at our Gurukul's primary purpose is to bring a meaningful way to gain knowledge and utilize knowledge. This is our, for lack of better terms, central thing that we are selling. To who? To students, right? So therefore, knowledge is very core foundation. That is what we are creating. That is our main. In any business, you have to identify what is the core of the business. Some businesses are, say, for example, Dell. Dell's main core is its distribution, its supply chain management. They are not necessarily really a good manufacturer. They are not a good designer. They have mastered the art of how to connect all the supply chain pieces and then sell. Apple is relatively very good at innovation. So like that, every company has a core principle to it. What is our Gurukul's core? Knowledge, right? Our so-called content. Because at the end of the day, school is there in many forms. But why are we saying we are unique? Bharatiyata, culture, new age curriculum, so on and so forth, right? Activity-based curriculum. So if you really look at our positioning to our students, we are saying that, we are good because of our content. So knowledge is a foundation element for us. It's core. So these 3 are at the foundation level. As we go further, if any other things have to be added, we will. For today, because our focus is on these 3 apps, I'm just restricting there. Then in the app layer, you find teachmate, studentmate, opsmate. We will have to have certain data related to these 3. I will show you one Excel now. You will understand it better. At the top layer, as I already mentioned, facts and future. Facts is nothing but, we infer various kinds of generally statistical inferences, generally, right? Max, min, average, so on and so forth. Yeah, that is a facts. So data already contains the fact. It's just a matter of aggregation. How many students? Already you have student registry. Count of the students is one of the fact. Then future is looking at the pattern of student enrollment. Can I predict next year how many students may enroll? Is all future, right? Such data also we will have. So this is the third layer, Intel layer. Yeah. So our data will be organized into these 3 layers as of today. So let me pause here at this big picture level. Are there any questions from Dhavalji? And who is that who has joined as Atmajyoti Satsang?
Oh, sorry, it's me, Vijay.
Okay.
Ashwini.
Yeah. Ashwini ji, so we have started a high-level discussion.
Yes, Vijay. Sorry, I joined only now, so I missed that registry and security part, what you might have mentioned.
Sure. So what we discussed is that, our data of the overall Gurukul will be organized into these 3 layers, the foundation layer, the app layer, and the Intel layer. And in the foundation layer, what you are seeing each of the box is a schema. Schema means it's going to contain multiple tables and relationship. So there are 3 broad schemas that have come up. Registry. Registry is nothing but a collection of all the major items in our Gurukul. We have students, we have parents, we have mentors, we have Gurukuls, we have assets, so on and so forth, right? Simply a list of them. We have to deal with so many things. So all of them will be in the registry. And then knowledges, that is our core content that we are offering. All the knowledge will be organized in the knowledge schema. Security will ensure at the foundation layer who can access what part of our data. So that is what the foundation layer is. Is that bringing clarity?
Yes, Vijay.
Okay, all right. Excellent. Dhavalji, so far so good?
Yes, Vijay.
Okay, all right. So if this picture is okay for all of you, then let me take you into slightly detailed perspective about this data. Okay. So what you're seeing here is now we are taking one level, going one level deeper. So for example, we'll be going into in the foundation layer, in the registry schema, what all entities can exist. Again, this is not an exhaustive list. Today, our focus is not on getting an exhaustive list. Whether we are okay to navigate our data world in this way, such a high level thinking is what is happening. Yeah. Similarly, you'll find entities and related description about other layers. Yeah. So let's go layer by layer. So in the foundation layer, in the registry schema, for now, these are the 6 main entities that I have identified. For example, there is students. Again, related to our these 3 apps. Okay. I've not yet gone into sales, operations, so on and so forth. We have students. We need a laundry list of all the students. We need a laundry list of all the parents. We need a laundry list of all the teachers, laundry list of all the gurukuls, all the mentors, right? And our graph is relationship graph. So each of them is related to each other in some way. Same child may be related to one parent as a child. Same parent may also be a mentor in the same school. So therefore, that same child also has a mentor relationship with that parent, right? But in that, that person is now a mentor. So generally, to represent such what we call as relationship kind of aspects, there are 2 ways we can represent that. One is a graph way. Graph way is you identify nodes and you identify the relationship among the nodes. This is related to this by this relationship. Gayatri is related to Prabhuji as a student. Gayatri is related to Shiva as a mother. So when you want to represent that kind of an information, Gayatri becomes a node and relationship lines will emerge from Gayatri to go towards the other node called Prabhuji, Shiva. Now Shiva is also related to Prabhuji as a student. There will be a line between Shiva and Prabhuji, right? So this is a graph way of looking at the relationship. The other way of looking at this relationship is what we generally call as an association table, an association approach, where, for example, let's say I want to represent simply a student-teacher association. So there, I will have 3 columns: name of the student, name of the teacher. That's rather 2 columns. So Prabhuji, Shiva, Gayatri, Shiva, Prabhuji, right? So like that, I will have a list. So what happens in an association approach is it's limited to a particular relationship. I have already defined the relationship as the association. Whereas a graph way is a lot more dynamic. I can find all the various relationships. Tell me what are all the ways Shiva is related to Gurukul. If I ask that question, I can find, he's a student. He's he can also be a mentor. So on and so forth, right? So graph gives a lot more dynamic flexibility, but we'll have to bring that aspect. So right now I'm proposing a graph approach for modeling that. As we go further, as you learn, if you find it today it is not feasible for whatever reason, we can go to an association and then come back into graph approach later. Yeah.
DG, how is this last layer, registry knowledge security, different from a database model that we're doing on the other day? Isn't it same here also you're finding the entities and our graph is like equal to some year relation?
So what we did that day was more of we took the viewpoint of teachmate, what all concepts teachmate has to deal with, what all concepts studentmate has to deal with. We didn't necessarily take a overall Gurukul model. We took a very app-centric view of the world. But that was necessary because from there, we identified so many concepts. Today, what we are doing is essentially, we see all these architectural work is iterative in nature. Iterative means we first start somewhere, like how we started. We took an application viewpoint and we started. And from that, we generated so much of content. Now what we are doing, if you really look at it, it's the same primary things that we identified organized in certain way. We did not have a concept of a layer that day. We did not have a concept of schema that day. So today we've organized them in that way. So from all that information that we gathered, if we do not put them into nice little structures that we can easily understand and navigate, it becomes too complex to think about. You cannot think about all those as we go further, right? We may end up having, say, I'm just guessing, okay, say maybe some 200, 300 entities. It is impossible to think about 300 entities all at once. But if you really look at it, broadly, all those 300 culminate in these three layers, in these eight, for example, for today, in these eight schema, or maybe 10 schema. So now you have brought the problem space into a manageable way of looking at it. You can deep dive and you analyze it. So therefore, you have to establish, yeah.
Pick up the entities, it will reveal the entities for me, right?
No, R graph is within the foundation layer, within the registry, right? The schema called registry. What are the items in the schema? I have students, mentors, parents, so on and so forth, right? What is the relationship among them?
All the relationships it will bring up bring up on the screen.
Yeah, that's a way to see for a human being, but at a data level, I have to still store this. No, remember this. What you're seeing here in the Google Sheet, they have to be stored somewhere. I will be storing all this data in some database. Okay, so in Postgres, I will have a table called as students. It will have a list of 1,000 students, 1 lakh students, whatever. Similarly, in Postgres, I will have a graph database. I'll have a graph schema in which, this for the registry, there'll be an entity called graph. And that R graph will show me among the registry items, what is the relationship. And that, how do I want to represent it on the screen is a separate problem. That's a separate problem. So you have to now disassociate your thinking from screen-based viewpoint to data by itself. How do you store, right? This is data when it is stored. Is it making sense?
So the graph sounds like just the ER diagram.
No. It is not no. R graph is among my entities relationship. All the registry entities, right? Registry graph. Think of it like registry graph. Yeah.
Yeah. So in the domain of registry, it is defining the relationship.
Relationship among the entities, not from a database. See, okay. I understand your question. There's in the ER also there is an entity relationship. That entity relationship is different from this graph relationship. So that entity relationship is about when I have in a database 2 or 3 entities, say student addresses, like example that we took. Student can have 1 or more addresses, right? So that relationship is more of a how is this entity and this entity connected together. Whereas graph representation is when among the entities. So now let's take people entities. Okay, people. Who is a student? A person. Parent is a person. Teacher is a person. Mentor is a person. How are they all related to each other? There is a very dynamic way. Shiva is related to Prabhuji. Shiva is related to Gayatri ji. Gayatri is related to Prabhuji. Prabhuji is in turn related to Darshan ji. Darshan ji is in turn also related to all these other people through some other association, right? So when you look at the human network of relationship, it's a dynamic, yeah. So to represent that kind of a relationship representation in a very social context, right? A graph kind of a representation is useful. So how it works?
Representation, like how, where are we using this?
Yeah. So say this is Gayatri. So say this is Prabhuji. Say this is Shiva. Gayatri is related to Shiva, and here Lord says mother. Prabhuji is related to Shiva. There it may say, again, depends on the traversal direction. You travel from here to here. So when Gayatri is a mother to Shiva, Prabhuji is a teacher to Shiva. Now,
Gayatri is a student to Prabhuji.
if I travel this way, he is a student to Prabhuji. So now if you see here like this, if you start adding other entities, it becomes a very dynamic graph, right? How to represent that in a database?
This is useful to us. Where are we using this, the whole thing?
If you ask a simple question, tell me the journey of Shiva. Okay, so journey of Shiva in Gurukul started as a student. Then he might have become a mentor. Okay, simple question. Let's ask another slightly complex question. Darshan ji may be a particular course creator. He may be a teacher for some course. He is also a overall Gurukul, for the sake of understanding, overall knowledge manager. A particular course before it goes live has to be approved by a knowledge manager, let's say. Then who has to be that? So when you go into application building and later analytics, so you'll find all these kinds of associations useful for you to provide the capabilities.
Where is this part?
This itself will be stored in this R graph. So that is the entity. R graph is the entity. Yeah.
And you see that everything has a K graph, then there is a
Yeah, for now. Yeah.
security.
Yeah. Makes sense? Okay. Shravanji, so far so good? Yeah. Okay. Dhavalji, Ashwiniji.
Yes, Vijay, clear.
Okay. All right. Great. So now, moving on, if you look at the next major schema, we have the knowledge schema. In the knowledge schema, we have K hierarchies, hierarchy of knowledge content, which we already have discussed. It's organized as so on and so forth, all that whole discussion that we had, right? And that is not necessarily the only way to organize. There are many other ways. So therefore, our schema allows multiple ways. So K hierarchies. You can organize it. Well, let's say we call it as 2025 organization model. Today, all our knowledge items are K assets. Our granular items are K assets. So now these K assets are organized according to, as of today, 2025 model of K hierarchy. Maybe after the 3 years, we all recognize, no, this is not working well. We have to now come up with a new taxonomy. So we will come up with a new taxonomy. So it can be called as either K hierarchy and K taxonomy. Which terminology is a better terminology according to you, Shravanji? Hierarchy is better? Sounds intuitive, right? Yeah, okay. So K hierarchies. Then learning paths. We have learning paths. Learning paths is how do you navigate this hierarchy? Yeah. And there also, today you may have given a particular way of navigation. Tomorrow you can come up with another way of navigation. So therefore, we have learning path entity. K assets. These are our most granular assets, right? This is what we need to guard. It could be a video, it could be a PDF, it could be a quiz, it could be blah, 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 right? Yeah. K graph is, again, suggestion is this, but as we deep dive, it may not be necessary. It may be just a simple association that may be appropriate. But as of today, at high level, that is what I'm thinking, graph approach, right? Okay. Then moving on to security layer, we have roles. So we are going to have a role-based security system. So each individual will have one or more roles, again, depending upon the context of the application they are choosing. And roles have, that's where you see two other entities, auth-n and auth-z. Auth-n is authentication related information. Authorization is auth-z, authorization related information, right? Authentication is who you are. Authorization is what you can do or cannot do, so on and so forth. Then if you go further, there is applications. The TeachMate for today has TM users, TeachMate users, and TeachMate application log, right? Teacher activity log. So these are the only two entities that I thought are necessary, because the rest of the things are going to come from the knowledge schema or from the registry schema. So the TeachMate application is certainly going to use them. Yeah. So each of the entity, so that is nothing but, let's say, knowledge asset cannot be modified by a teacher made application. it has to work with the registry process, right? Teacher can modify. TA log is teacher activity log. So what the teacher is doing, created a new content, modified a content, looked at the student data, so on and so forth could be, right? So those activities we are logging. Because all of this is important from an inference for the Intel layer. Yeah. Okay. Next, similarly, for student also you have SM users, that is nothing but student mate users, and SA log, student activity log. Same you have ops mate users, and ops mate activity log, right? So as we deep dive, we may find more entities to be added there. Then last layer is the Intel layer. There are two main schema, facts and future. Again, this is a suggestion or a currently example. It is not an exhaustive. For example, for facts, yes, progress metrics of student, various kinds of metrics we need to store. Student streak, consistency metrics of student, right? So similarly for forecast, various kinds of forecasts. So this is the broad approach that that we can take. So again, let me pause here. Any questions?
Database is generally owned and by the apps, but can also be used for analysis by others, right?
So that's where, if you see here, there's a boundary. A schema is a boundary. So who owns that schema? Which app should update that schema? Which app can read from that schema? All that we will define in the security layer. As an example, can TeachMate go and update security schema? No. So then who can update entities in a security schema? A security app. We will have a security app. So like that, we will define that boundary. So now if TeachMate, then what it can do with security schema? It can only authenticate and authorize.
Yeah, but in the database, having a separate layer for apps, why that should be at the database level and not local?
Can you refine your question? I'm not able to understand your question.
At the database level, a app relate the teacher, let's say student log.
Yeah.
Student, we want to know students' context at the moment.
Yeah.
What we spoke.
Yeah. Yeah.
What student progress.
That is the metrics. There's a metrics. That is the inferred data. That is not the activity.
No. Okay. So this is data at rest only.
So the student, progress metric, say for example, as of today, how many courses Sriram has completed? You ask that question.
That's at rest.
That's the metric. Okay. Computed. Okay. So he has completed 4 courses. Now you ask the question. Okay. When did he complete? Give me a time log of these 4 courses. So now you need a deep dive, right? See, because data, you show aggregated data. 4 courses is completed. Then you ask the question, show me in what time, show me the time scale of this, time movement of this. So how do you get it? You have to go to the activity log. Where is the activity log? Is owned by the student, say student mate.
So this is still data at rest, which means once you have written, you normally, if this is not dynamic to the context of a particular transaction.
Okay, so this last sentence, what do you mean by that?
Let's say,
yeah,
now a student is interacting with an AI app.
Yeah.
Now in the AI app, you have kept a context, some dynamic context for that AI app to know which level that he is from, which subject is looking at, what was the topic, what was his previous questions and answers, where he abandoned something, or so some context is there.
Given to the LLM. Yeah.
To be given to the AI sometimes.
Yeah, the LLM. Yeah.
The-
Yeah. Yeah.
So now this is maintained and it's valid until that particular session is there. After that, it is not valid. You just drop it,
Yeah.
right? So that's a dynamic data or
Yeah.
a context-based data.
That is also a fact. For example,
So that is, I was thinking that is what you keep here. So
where
in the database.
which data? See, all of this is in the app schema. That's a matter of discretion. So where should we keep what? So for example, is it a metric? So for example, the context is changing. Is the context, if let's say you ask the question, as of yesterday, what was the context? As of day before yesterday, what was the context? And is context a app specific data, or is context a Intel specific data? Is a matter of discussion, and therefore it's a matter of where I want to. There are three layers. If you see the picture here, there are three layers: foundation, app, and Intel.
We can always say this is three types of data also, right? This is a different kind of data at the lowest level.
Yeah.
Foundation level data, type of data, app type of data, and the Intel type of
Intel type of data. Intel type of data is inferred from the
activity also.
from the all the below layers. It derived. Yeah. You cannot go and simply create a fact by yourself. You have to derive it from the data that is there. And application is the let's say the surface in which you have all the transactions, what the student did. That is what your content for ingredient for your Intel, right? Also, what is the content for your Intel? Foundation layer.
And tell you why our knowledge is all in communication. Most important is when a call is being made or a session is happening. For that session, there is a sequence of data that is collected where all the entities who are working on it have to keep. Otherwise, you don't know for this particular session or a call, which is a dynamic thing, what is my role? So there's a call block or a session block that will always be there. Now that goes from place to place. Because if one entity is started, the other entity should know for this block what should be there. Now normally this is not stored in a huge database, but it is a very database. Until the call drops, it is useful for all. Once the call drops, this is not there. Or once as long as a transaction is going on, there is some context data for that particular transaction where everybody has to know, right? So this data is also kept in the database if it is useful for all the people to easily access it. But it's a very dynamic data.
Yeah.
If somebody accessed it beyond the transaction time, it is lost.
Yeah.
Or if somebody accessed it and the transaction got lost and he's working on it, then it is wrong data to work on.
Yeah.
Maybe this next transaction was on.
Yeah. Yeah.
So these are very tightly realistic data.
Session specific data.
Session specific data.
Yeah.
So they all normally verify again and again, okay, is it the same session or the session ID changed
Yeah.
or something?
Yeah.
So I was wondering, that is also some app related data.
Yeah.
Basically a call app or something. I was wondering why it should be kept here. Now what you're saying is, this is not that, this is data at rest only.
Yeah, right now we are looking at data at rest, but also when movement is happening, right? That is what the session is all about. Movement is happening. There is some data that we may have to capture and persist
Until a particular time.
for a period of time. So when I use the word data at rest, it is not necessary that this data is going to be there forever. Even every data, so in any data modeling, the concept of duration of the data is very important. That's why if you see below layer data, that is the foundation level data, has a relatively longer duration, right? So therefore, a session data may be a fairly shorter duration, right? Which is, we typically call as ephemeral, comes and goes. Sometimes it may be as ephemeral as when the process is running in the memory, only till then it is there. The moment the process goes away, data is also lost, right? So that is as ephemeral as that, or it could be for one day, it could be for 1 week. So therefore, that is a duration aspect. We will, as we
Fees that the website stores. Is it like
is also like that. It's a context specific. Again, the word, we have to be very, very clear when we start using these words. Context today, because of LLM, there's a different meaning associated with context. Okay, the context in the subject of LLM is what is the background information that you're giving to the LLM. Whereas when we use in the context of a session, right, it means that it has some information that the browser can use so that it can make some decision in a way very similar conceptually to the background information that you're giving to LLM. So we need to decide where such data should reside. Some of it can reside simply only in the browser. Some of it may have to be persisted. Case in point is, especially session data. Let's say user has initiated a transaction, let's say payment, right? Fee payment. So it is not that, in the back end, only one service is servicing that particular call. The payment may be multiple components may be involved in the back end. One component is initiated. Another component may have to pick up that work. Another component may have to complete that work. Or there may be two instances of the same component running. So how do they share data? So that is typically where all this session cookie kind of a context sharing information comes in, right? So we have to go deep dive in that particular situation. Let us identify.
Okay.
Yeah.
Yeah.
Any other question or any other point appearing to you?
So
And
you
also
say,
there will be some facts and future are fine. We always used to have past data. Example, that's only
Past is in the apps. If you really look at it, past is in the app and the foundation. So nothing but that is the transaction layer. That is where all the transactional data is going to be there. So inferred data is in the intel layer. Okay. Inferred from the past. So the yellow and the blue layer represents the past in a way, and the purple layer represents the in a way inferred present and future. Is it? No, you were about to say something.
For example, the logs, which are only not used by the system anymore,
Yeah.
they are just dumped to something. It is
Yeah.
just a past.
Just a past. Correct. So, and there can be various kinds of logs. And the log that I have recommended here, for example, when you go to the TA log, right? It is not a log of every nitty-gritty. No. It's like applications will generate various kinds of, I am opening this function and I did this in this function. So there are various kinds of messages developers may use. We are not talking about that log. We're talking about business event specific logging so that we can use that to make meaningful decisions. So we'll have to identify such events. These are business event logs.
Okay.
So if this approach is in principle sounding okay, but before we go further, Dhavalji, do you have any particular viewpoints or questions that you want to raise now? Dhavalji, are you there? Okay, all right.
this thing what you brought this data model, is it like a you created this, or this is something which is available in the this kind of modeling system is already there?
Yeah, so the principles means what? Layering is layering. When you have a complex system, you deal with the complexity by, first of all, segregating them into layers. So you deal with the layer related problems. Break, right? So how do you break? Layering is a breaking strategy. Schema broken into schema is so that way human mind can operate on few things at a time. So when we have a clear focus, registry means what? List of all the different kinds of items. Very easy to relate to that concept.
Really, but what we registry is that where it stores the system files and all that, right? In Windows operating system, if you see the registry.
Okay, think in this, that's a good analogy. Think of registry in the school context. You would maintain an attendance registry. You would maintain my inventory registry, right? Why is it a registry? Is this item in my school or not? Go and look up in the registry. You'll go and see in the registry. Oh, this was given to Timaya day before yesterday. Registry tells you, right? So registry is where you will find all your items of your universe. So that's why the registry. So like that, it becomes now easier for you and me to communicate. Yeah. So, okay. So where will I find all my content that we are teaching? Okay, let's go to the knowledge graph.
So the entire data, irrespective of the entities or layer, everything is dumped into the registry, right? Registry holds all the data about everything about Gurukul.
Not all kinds of data. For example,
so registry holds the entire data related to the people entities.
Not just people entity, it could also be some kind of other. Again, it's a matter of discretion during design. For example, students learning particular content, right, is also something like important information. So I can have a student activity log also in the registry. But I have right now decided to keep it in the student mate. So like that, it's a distinction that you and I need.
Also store data, right?
Yeah, that will be in the student made database. That's why if you see here, as you go further, see here, student mate has its own currently only two tables, SM users and SA log. Make sense?
Yeah.
Yeah. Okay. Ashwini ji, can we take the next step? Is there anything else?
Yes, Vijay.
Okay, all right. So what I will be doing is, I'll share all these documents with you and all the people here, but primarily for Shravanji and Gayatri ji. So now, Shravanji,
Yeah.
what is coming to you as a next step based on this? First of all, has this brought clarity to how we can take the next step to you? Because this is not yet at a see, now you need to go and define okay, what does the student's schema contain?
Looking at types of schemas. Earlier we were just making schema for, I was thinking we make schema for a particular function.
Yeah.
Now, depending upon the type of function,
so
it's one more layer of arbitration. So registry will have registry knowledge, security will have one type of schema and all the.
Yeah.
That's fine. And
So,
within registry, of course, there will be
multiple entities. And as we go further, if let's say, if we find that, it is better to have sub schemas within that schema, that is also perfectly okay. It's all about
separate schemas. We find
that, it is becoming too complex. See, the idea is very simple. Idea is smaller the unit of information that we have to deal with, better is our decision making. So that's the fundamental principle of software organization, right? Don't try to complicate things. If there are too many aspects, cut them away, see what is that interrelated, smaller, immovable concept, make it as one unit, right? That's the idea, whether you're dealing with the data modeling, that's the idea whether you're dealing with APIs, where you will be organizing APIs into a similar clusters of microservices. So the whole system is very simple. This entire data model, now you're seeing it as 3 layers, right? So this is our foundation layer. And then we have our app layer. And then we have our Intel layer. So this is our data. Similarly, our APIs. Middleware, API side. It will be divided into various microservices. Microservice 1, microservice 2, microservice 3. Correct. And what is the service? Service is nothing but a collection of APIs. Correct. So the fundamental idea here is usually a microservice. Again, just a simple rule of thumb. A connected type of thing which is manageable by, it's a famous thing, not more than 2 to 3 members of a team. A 2 to 3 member of team should be able to within one day understand it, start learning how to manage it. That's the simplest segregation technique, one of the simple technique, right? So we'll be breaking our the backend into such small.
Supposing student has to do a fee payment, Paytm is a microservice?
No. So let me give an example. So say payment microservice could be there. Okay. Payment microservice, it may deal with doing the payment using say Paytm. It may deal with
net banking,
right. But if you really think about it, there is something related to payment where a payment request is initiated, and from there's some life cycle till they have paid to us. So this microservice handles all of it as an example. Then we talked about authentication. So there can be a RN microservice which handles only authentication. There may be a RZ microservice which handles all the authorizations.
So these are like already done apps which we are using, right?
Not necessarily. This is where
already available services which we are integrating to our app.
could be, or we may have to. For example, in the Google, we'll have to build it. If it is not there, we'll have to build it. So in the Google ecosystem, this is already there. We have to learn how to use. So it maps to Google as a provider for the service. See, when we are generating the architecture is independent of the provider of that service, of that architecture. Or in other words, I have identified I need a registry. If I already have a database which already supports all of this, I will simply say this database is my is my registry database, right? So this is modeling. Modeling is where I identify all the pieces I need and the structure and the relationship. Who is providing it? Oh, Sravanji is building one thing because it is not there anywhere at all. Or no, it's already there in Google. Why are we rebuilding? Reuse. So you map MS3 to that.
Yeah.
Yeah.
So I take supposing auth.
Yeah.
There is already a Google auth process.
Yeah, you use it.
That's
You build around it. Yeah.
Because you said MS is a
Microservice, APIs. Those APIs are already given by Google. So you say this is already provided by Google. If any additional thing is needed, as an example, knowledge database. How the knowledge database is going to be? We will not be maintaining all the assets. Already LMS is going to maintain the assets.
Yeah.
We will have certain metadata that enables us to navigate that structure. So our knowledge schema will be built around mostly Google LMS, right? So it's not that, everything we have to construct by ourselves. Yeah.
Yeah.
So this is a microservice layer, right? This
But
is-
then you don't call Google Classroom microservice, right? Classroom itself has a microservice, can you call?
There are, see, microservice, as the name indicates, service, and it's micro, right? And typically, it is a terminology associated with back-end stuff, typically, right? So therefore, this is a back-end layer. So there's a data layer, there's a back-end layer. And then all our applications, all our user interfaces, what we generally call as front end, sit at this layer. So this is where, we have teacher name, we have student name,
Yeah.
we have ops name, we may have some sales name, so on and so forth, right? All this is our front end layer. Yeah, our front end layer will not have direct access to data layer, will always come via the back end layer. The back end layer is also generally called as an API layer, right? So this is overall architecture. See, like how I've organized data into these three layers, our overall system, our overall IT system is essentially nothing but these three layers. And this is running in some infrastructure. This may be running in some, say, Postgres database on Google. This may be running in some, say, some cloud run instances in Google. And some of it may be a Google SaaS service. I don't have to worry about it. Some of it may be hosted on our website. Some of it may be accessible from Google Firebase. So like that, those are all the final destinations. So this is a high-level functional architecture, right? Then comes the physical architecture. So that we will go next. Is this picture making sense? Yeah.
So
Yeah.
how do we, as a process, generate all the required API services, or how do we think of a system? How do we generate a list of microservices for that system?
Great. It's a iterative process, like I said. Like the data, it's an iterative process. So therefore, first we have to establish. See, it's like when you recognize the immovable, and then on top of it, something movable becomes easier to design, right? That's why first you have to establish the foundation, which is the data. That's why we are doing this work first, right? See, we cannot come from here. Here, you will have a look at how the user wants to view the world. But the user's view of the world is not necessarily the data view of the world, a data model of the world. So therefore, we are arriving at it from both the sides. What Double G is doing is coming at this universe from this viewpoint, whereas you are going at this from this viewpoint, right? And this is where they both meet. Yeah. And both are important to establish, because some of it will influence this, some of it will influence this, and so it's a mixture. Over the next 1 or 2 weeks, we would have a pretty decent understanding of all these pieces. Yeah. So now coming to your question, the first thing that we should now establish is this data layer, right? So now, to a large extent, our key schema items have emerged. Key schema and key entities have emerged. Now we need to model it, meaning what? For example, identify registry, add some data, identify some knowledge, add some data that we are going to organize. And as if you're a teachmate, add some data and see whether you're able to query, right? So just by taking these three, registry, knowledge, and teachmate, are you able to run some SQLs? Or you can create a small microservice, say teachmate microservice, which requires this data from these three. And are you able to fetch it? That's the experiment. If you do, you'll gain a deeper understanding. Yeah. So first let's do that. Yeah.
So like now Rajita creating a GPT.
Yeah.
And we call the API from GPT, where the API will add her content into a particular course, particular lesson, particular topic, and we call the whole thing is can be called as a microservice.
So for example, there may be a let's
Now she has a quiz generator GPT.
yeah.
It will directly.
Yeah.
We can call call the API.
Yeah.
Which will take this quiz.
Yeah.
And put it into the exact course. The
Yeah.
whole thing can be called as a microservice.
Yeah. So let's understand this better. So now, for example, let's say in the back end, you may
Vijay ji, sorry, can you please stop sharing? I'm not able to see the whiteboard properly.
Oh, sorry. Is the whiteboard visible now?
Yes, yes, Vijay.
Really, sir. Yeah. Yeah. This is what we have written, Ashwini ji. So what the PPT that I was sharing so far had these three, right, at the data layer. Then, in the middle is our backend or API layer. And at the top is all the front end work that, let's say you and Dhavalji and others are doing, right? Are you able to relate to this?
Yes, Vijay ji.
And now the question that Gayatri ji asked is, okay, so now GPT. Now, GPT, what is a GPT? First and foremost, the GPT is available to the user as some kind of interface here, right? Teacher mail. Teach mail. It will be there, right? Okay. Now, it uses a GPT. Now, a GPT itself, say for example, LLM, is a microservice. As far as our model is concerned, it's already a microservice. You and I are not developing that microservice. It's already there. We are using the microservice. That is why this one, uses that microservice and generates. Now, whatever it has generated has come to the front end, right? That is how she's seeing it. Okay. Now she may have a button there which says that approved. As an example, I'm saying the simplest workflow. Let's say teacher generates, say, lesson. At this stage, it talks to LLM. And then the teacher clicks on, say, approve. At that stage, let's assume it has to get stored in say, Google Classroom, right? Let's say this is the simple workflow that we want, right? So now generate lesson. So she will be clicking here in the front end. As soon as she does that, it goes to LLM. Okay, all of that. Okay, great. Now she clicks a button here. When she clicks a button here, it has to come to Google Classroom. Now, Google Classroom is part of our, say here, foundation layer, right? Knowledge. It has to come and sit here. So now, who brings that? So there is already a Google Classroom microservice, which is nothing but whatever microservices the APIs they offer. We may also add some little bit to that. This whole thing, this whole sandwich, we call it as our knowledge creation microservice. We can give a different name. We'll think about the proper naming. Naming is very important. Then what happens when they click on approve? This stage. So let's say this is 1, this is 2, this is 3. So this gets invoked at stage 1. Yes. When I click on 2, stage 3, this comes, and this also comes on right side. Right? That's how the data will move.
You're covering it, so tell the sequence again.
Yeah. Right? So just to shadow them again. So 1, 2, 3. When 1, 2, 3 happens. So 1 happens here. Yeah, so this is 1. And 1 also uses this. So this is 1 and this is 1. And then 2, when they click on that, it has to get stored here. No? So 3
3 and
and 3. So this is how the data will move, right? Now, at the same time, our one of this microservice, no, that is why we would have written our own custom microservices, right? Either our microservice or somewhere we have to send a signal to our facts saying that, hey, a new course has been approved. Now that has to do some computation, number of courses approved, something like that. So all that kind of thing will happen in the backend layer. That is not even visible to your teacher, because when you go to OpMate, because what happened in the TeachMate has to reflect in the OpMate.
Yeah.
Or maybe the teacher only may have to see the computation later. So like that, all those kinds of things will happen here.
it doesn't end with storing in the database.
Ah.
Notification for somebody else.
Something else. Correct. So fundamentally, that is how our overall architecture is. Something happens, then we send something called as a notification or an event. This happened. Now there may be 100 parties in this who are interested in.
You show only 3 instances. I'm seeing some 50, 60 microservices that you have to use.
That may come up as we go further. As we go further, it will naturally evolve.
Form. Notification is coming to my Gmail.
Yeah.
So you have to-
Yeah.
Okay.
Like that.
So yeah.
So at the end of the day, all of this is, a structural view, but essentially like this, you have workflow,
Yeah.
teacher workflow, student workflow, our sales workflow, marketing workflow. So all we are doing is how do we break this workflow into smaller manageable units and containing them here. So workflow knowledge
Yeah.
gets.
Workflows usually, because
That's all.
so
There is no. We will not boil the ocean. Like how we have started now. We have started with the education workflow. We are focused on one particular part of our overall system. So like that only.
like that.
Yeah. Now you already have a workflow. Rajita, what she is doing is a workflow. How to generate lesson. Right? Yeah. So like that, if you think about it, overall Gurukul, there may be such 100, which is critical. Today, that is where we have started. So it's all about, our work is all about process automation. Process automation. So what is fundamental to automation? Process. There has to be a process. Who defines the process? Our business. So we understand that process and we see how to automate it the best. That's all our work is.
So what would be the next step to this?
Yeah, so like I was suggesting, what Shravanji and you can do is, imagine you are a teacher and you're creating a content. And you need to now store that content in our schema. So it involves registry, it involves knowledge. For now, don't worry about security for now. It involves TeachMate. So think of these 3 schema and think of what entities are needed for this simple use case. The teacher goes and generates a lesson. So which means you need the student teacher information. You need the knowledge hierarchy. You need the the LLM connection to generate that, some kind of an approve. So you don't have to worry about creating the UI. Don't worry about the UI. But what entities are needed and how the data flows through your API, if you can now visualize that in terms of what I call as, I'll just share the screen again. There is something called as a sequence diagram. Okay. And this is extremely valuable. Yes. Okay. So this is called a sequence diagram. Sequence diagram is, see what you saw in the last diagram that I shared, that is this diagram. This is in a way a static system. a snapshot of our system from a data viewpoint. Snapshot, it's a picture, right? Click, frozen. Whereas sequence gives you kind of a dynamic view, movement view. Okay. So here, what is happening? Alice is calling Bob, and Bob is responding back something. Bob is then sending something, right? So like that, if I were to write it for our use case that we are seeing on the whiteboard,
By the way, from communications.
this is what you are very, very comfortable with, right? But in the app world, this and then this have to be brought together. So let's say, for example, generating and storing a lesson, right? This is the context of the flow. So who are all involved? Teacher is involved, and LLM is involved. So what does the teacher do? Request for lesson generation, right? From LLM. And now what the LLM does to teacher? Sends the lesson, right? Yeah. Next, okay, this is just a note over. If I want a note over teacher, teacher is assumed to have already logged into the TeachMate app. Okay, so this is a note. Yeah. Okay. So now this is okay. Then what happens? Then the teacher, teacher will now say, click on, say, now we have
What is this tool? It generates the sequence diagram from
from what you're typing.
from the chat.
Yeah. No, from what you're typing. Yeah.
Sequence diagram.org.
From the
I'll share this, and this is the way we will be documenting our content, right? Our movements. I want for all of our workflows, each one of us has
What is
two.
the tab?
It's called sequencediagram.org.
Sequence.
Diagram.org. I'll share all this, right? Similarly for database diagram, no? See here, there's a dbdiagram.io. This gives you a great flexibility to just simply add and start seeing. And it now has a wonderful add-on called as Run SQL, where if I go to the app, Run SQL app, you can see your structure, you can write query, you can also add some sample data, you can start seeing the query results, right? This becomes very easy for you to play around.
See Swagger. By the way, Swagger.
Is good for this layer, the API layer.
You have typed all this, right?
Yeah, you have to type. Yeah, you have to type. Yeah, no, this is a sample one that it generated. For now, for our schema, you have to generate this.
It's like I make the table and it gives the code.
Both ways. You can do both ways. You can add a table and then add content there, or you can add a table. So text to diagram, very easy. So now you go to GPT and ask the schema, no? You simply copy and paste the schema here, you'll start seeing the diagram. Or you go to Run SQL and you'll start seeing this, right?
What is that thing called there?
Which thing?
dbdiagram.io.
Okay, just a moment.
So just in the chat, send me the tool name.
Yeah, I will. Yeah. So Gayatri, what is your question?
This is called.
This is your.
What is this?
This is nothing but you can call it as data modification language, DML. In SQL, SQL is the programming language for you have two types of SQL commands: DML, data modification language, and then DDL, data definition language. Sorry, this is DDL. Right? Yeah.
So I can ask GPT to give me the structure and it will give me the DDL.
You can simply say, give me the DDL for creating this schema in Postgres, and whatever it gives, you can bring it here. Either you can use the DB.
Tables, right? Why are you still calling them as schema?
No, this entire thing is schema. Schema is nothing but a boundary. This is 325, 7253. 7253 is one house. In that house, you have room, kitchen, all that. No, different entities are there. Now, 7251 is a separate house. So that's a separate schema. It may have a different configuration.
Schema is a set of elements
Yeah.
put together.
Yeah.
Their relationships.
Yeah. Yeah. So it's a way to organize. You cannot put all these 1,000 homes in one big hall and one big kitchen and one big room, right? It could have been done that way. But now, this entire thing has been broken into smaller pieces for easier organization. It's exactly like that. Schema is a...
One workflow and create a schema out of it.
Don't think in terms of schema for workflow. Workflow is from a user viewpoint. So that's why you're dealing with this layer, you deal with the workflow. This layer, for the same workflow as you saw here, it may use services from multiple microservices. Can you see here? It can use data also from multiple red boxes here, right? So it is not that there's a one-to-one relationship. Simply take a workflow and plop it here. No. But first you have to model that. You have to model this both. From that, this is influenced. From this, that is influenced. Many times. That is the story. You start the story. From the story, you will be able to come back here. And that is what we already have done now. To a large extent, it has come up now. Now you need to start refining it. As you refine it, you will add more and more entities as you refine, right? Yeah. Now coming back to the sequence diagram. So teacher asks the LLM and LLM has sent back the lesson. Okay. So the arrow is incorrect. LLM has to send back the lesson, right? Now teacher will click on approve. And for the time being, TeachMate of course, the teacher is talking to LLM through TeachMate UI only. In the first one, no, not directly to LLM, right? So this is incorrect, actually incorrect. So what we can write is, it is TeachMate UI, right? That's what the teacher is actually talking to. And it is a TeachMate UI, which in turn is talking to LLM.
So from this, like making a sequence diagram like this, what are we arriving at? How does this benefit me?
It helps you to know, you see, the workflow is becoming clearer. Otherwise, it is all in your head. And what is in your head may not be in my head. This is a flow chart.
It will be easier if you know what functions you're doing, what all it is dealing with, where to get it from, what APIs you call in that. So this is printed. The backend, they are trying to give all those APIs and all those changes. For our front end, it is very easy that I need to do this.
Yes.
For that, for the first thing, what API to call, what are it changes. So that information you get from one sequence.
Our coding, think in this way, is going to be only 20% of our effort.
Yeah.
Majority of our effort is in these kinds of Design, what I call as design. Design 80%, development and yeah.
The whole development cycle coding is only 20% or maybe even 1% now.
Yeah, right? Yeah. Okay, so now coming back, so teacher will ask, click on approve.
So
Yes,
just
but by the end of the
let me
day,
show
you
you
are going from front end
JG.
to the data.
some function that I have seen for student and teacher grade. Shall I show you here? or-
Yeah, so you're getting a hang of this? Is this okay? So I will share all these links along with whatever I've done.
Yeah.
So
This-
yeah,
I understood the structure.
Yeah.
And the kind of decision we want,
yeah,
and also the tools to represent those diagrams.
yeah, yeah,
Now, what we are really look at is the functionality
yeah,
of all the apps
yeah,
to refine our
Yeah,
schema
yeah.
and also our app.
yeah.
API.
So therefore, I will say, don't already think in terms of all the apps. Just take one workflow, which is nothing but the teacher generating the lesson and identify.
That is what talk about.
Yeah,
So, Vijayji, I have an input here,
yeah,
which I think will bridge the gap between what Shravanji is saying and what, we are discussing right now. When you want, I can walk over that, which will kind of like clarify that.
No, can you say it briefly? What is that you are referring to?
Yeah, I mean, I need to present that in order to explain that.
Okay, so I have only another 5 minutes. So therefore, if it is going to take more time, we can regroup later.
Yeah, because I mean, what Shravanji is talking about, from a front end perspective, how will we be calling the APIs and what are the structure of data that we will need, will add the final context on the data. So this is very good from a, core data perspective. But if we do that exercise from a front end perspective, it will give a lot of clarity on what is the actual workflow looking like and what data will be needed for what things.
So what we can do is, tonight after the executive meeting, anyway, the four of us will need to be part of the exec meeting. After that completes, we can come together again on the Zoom.
Yeah. It would not take much time. It will be probably 15-20 minutes of, that process explanation and, probably, yeah.
Talk now, you have office work.
Yeah, I have to, yeah.
Yeah, later again after
After the exec meeting, yeah.
But meanwhile, what he's saying is, you come up with as much of the stories as possible.
Only one story I'm saying. Right now, don't also
One story.
one story. For this story, go into all the details and develop a full-fledged working prototype is what I'm saying. Shravanji, what I'm recommending is, see, I think that,
You're not looking at the.
No, right now-
To design, you want to really see how it works once.
yeah, reason is, Shravanji, all of us have to become really familiar with the tools and the whole approach. Then it becomes very easy to flex our mind. Otherwise, we'll be doing a theoretical work. So just take one story, implement one microservices, which will store a lesson and create a database. So that way you get a hang of the whole flow.
Okay.
Yeah. And then, as we refine it with the double G. So the approach I am taking is, when all of you get a hang of these tools and the entire process, actual design will begin from next week. In a way, iteratively, we'll be improving.
Just for once, just write down the tools that we were trying to look at so that everybody else can understand the same tools.
Yeah.
I mean,
So
not necessarily.
So for example, at the front end layer, in order to really see the UI, we can use a tool called Figma, right? Figma will enable us to see the front end screens and the front end flows. And then in order to see the interaction between the front end and the back end, we can use the sequence diagram .org, right? This helps us to see the movement, yeah, between these two layers. And in order to model the data, we are looking at DB diagram.
Okay.
.io, right? So run SQL is part of the DB diagram.io.
Yeah.
So you can also, if you want, you can run SQL. Or you can also directly take it to your Postgres database. Right? So the ask is right now, the ask is the Shravanji. Number one, create lesson workflow. Okay. In sequence diagram.org. Okay.
Okay.
Number two, identify microservice and APIs for one. Don't worry about everything else, but only for that. Okay, is it one microservice? Am I going to be using the Google microservice? Yeah, that is what number two step is. Number three is create the DB for one. Then last but not the least is
The DB comes in the DB diagram.io, right?
you this is just to see, but you will eventually have to get it into Postgres.
You have to create a DB in
Postgres, right? Fourth, last step is automate 1, 2, 3, and demo. Right? Which means actual working. 1, 2, 3 should be working.
Automate.
Automate. Meaning, see, this is just a diagram that we'll be creating.
Automate.
Huh.
I think that's another tool.
No, sorry. Okay, so let me call this way. Create the software.
Okay.
Create the software.
Yeah, that's right.
Okay.
For the whole thing, so that we can see
We can see this whole thing working, right? So this would have given this team, that is Gayatri and Shravanji, a complete view of how it flows, right? And that he will worry about. He will use ChatGPT, he will write in Python. The microservice, he will, if at all the custom microservice is needed, he will create Node.js, whatever. Let him worry about it. You will help him by saying that, hey, this is already available in Google Classroom. I have already explored this API. That is how you will help. And you will also help by bringing Rajita into the conversation by saying that, look, this ChatGPT, this is the structure of the data. When I click on this, this is how it is coming.
Can I do this thing in an automation tool also?
You can also, okay, if you want to go down that path, you please go down that path. Let him go down his path. So that way, let's explore both the paths.
Sometimes automation thing I can understand a bit.
Yeah.
Because all these things have, but creating the DB may not be part of the automation.
No, in your, for example, bubble or make, whichever you're going to use, you'll be able to define this. Yeah. And meanwhile, our Dhavalji is, maybe in today evening's call, we can see how much progress Dhaval and team have made. They're purely working on from a front-end viewpoint for the student mate. So that's a separate, let's not worry about it. So what we are now figuring out is, how do we integrate the TeachMate workflow? Yeah, this is just a prototype of that. It is not the actual design.
Yeah. More one horizontal bar of the whole system.
Of the whole system. Yeah.
We generate it that way.
So. Yeah. It's clever. Yeah.
Okay.
Ashwini ji, Dhaval ji, is this okay? And any other comments?
It's okay, Vijay.
Dhaval ji?
So this is mostly from a teach-mate point of view, or we are also discussing this about implementing this strategy in the student-mate.
the same strategy will apply to StudentMate, but right now, the whole solution development approach is being experimented using the TeachMate, because Gayatri ji is quite comfortable with Google Classroom, and there is no major custom UI needed for this work. So therefore, it is being experimented in the TeachMate.
Okay. Got it.
UI is still free of all this. You can have a UI. UI design is not being talked about here. It's from there below. How a whole thing works in the system is what.
See, what I mean, to be very short on this, like UI, what happens is UI is how it works. So what Vijayji outlined the first point, right? Create a lesson workflow using Figma. So how UI is expecting the data from the backend, what is the shape of that data, whether that will be feasible for UI to work. There are sometimes some data, while from a backend perspective, it seems that it will be feasible for the UI to work, but actually from a UI experience, it might not be feasible, and we might need additional data or data in different format, etc., etc. So typically what happens is, when we discuss that UI structure, data structure, that what is the interchange that is going to happen between UI and backend, that time we all need to sit together and finalize on what is that interchange that is going to happen. Because that is what UI will use and function on. Otherwise, what will happen is, sometimes you develop the entire API structure and entire data structure, and then I come into picture and we say that no, this is not going to work because UI expects it in a different format.
Certainly, Dhavalji. So
Yeah.
this design, if you really look at it, there are two integration points.
Yeah.
UI, that is the front end, and back end, they have to learn to talk to each other.
Correct.
So we have to learn to define the interfaces. See,
exactly.
It's not a complex problem. This interface definition and adherence to interface definition is critical between two layers, where my pen is pointed right now. And this interface layer is within this Shravanji and Gayatriji's team, but this is also very important. But everything is an interface-driven design. That's why these are big components which are separated. Then this component, the front-end component, can evolve by itself as long as it adheres to the contract defined by the interface. This can evolve by itself. This can evolve by itself, right? So we'll separate the concerns. So that's a valid point that Dhavalji is making. As we dig, over the next few days, this Saturday when we meet, hopefully we all can meet for a physical get-together, where we will complete the demo that we are working on, and we will go into the deep dive, because Dhavalji wants to get the screen flow frozen and the interfaces frozen.
Yes. Yeah. So that's the whole thing, that it will be probably, it will be helping the backend team if it's a collaborative exercise, and avoiding rework later. Even if I don't end up developing the front end, I might help the people, backend folks to think in terms of front end, which is what will help.
Certainly.
Yeah.
Okay. All right. Then can we end? Yeah. We'll end with a prayer.